Hello, we discuss about the estimation of reducing sugars by Sumner's method. Myself, Dr. Kamthane DC. Aim to estimate the amount of reducing sugar by Sumner's method. Principle: reducing sugars have the property to reduce many of the reagents. One of the such reagent, this is 3,5-dinitrosalicylic acid. This is also called as 3,5-DNSA. This 3,5-dinitrosalicylic acid is converted to or reduced to 3-amino-5-nitrosalicylic acid in hot alkaline condition. These reducing sugars are responsible for the reduction of 3,5-DNSA to 3-amino-5-nitrosalicylic acid. This method tests for the presence of free carbonyl group, and therefore these are called as the reducing sugars. This involves the oxidation of the functional aldehyde group present in glucose and the ketone group in fructose molecules. At the same time, there is reduction of this 3,5-dinitrosalicylic acid to 3-amino-5-nitrosalicylic acid in hot alkaline condition. A reducing sugar is any sugar that is capable of acting as a reducing agent because it has a free aldehyde or a free ketone group. Example: glucose, fructose, maltose, lactose and galactose. Requirements: standard sugar solution. For this 2.5 gram sugar, it is dissolved in 100 ml of the distilled water. Next requirement: pipettes. Next, screw cap tubes, boiling water bath. Next, 3,5-dinitrosalicylic acid reagent. We see the preparation of this 3,5-dinitrosalicylic acid. Moist 1 gram of this 3,5-dinitrosalicylic acid with few drops of the water. To this add 20 ml of 1 normal NaOH solution. To dissolve the complete acid in it, add 30 gram of the sodium potassium tartarate and make the volume up to 100 ml with distilled water and then filter. Then we have to see the preparation of the standard glucose solution. For this 2.5 gram of the sugar, it is dissolved in 100 ml of the distilled water. 1 gram is equal to 1000 milligram. Therefore, 2.5 gram is equal to 2500 milligram dissolved in 100 ml, and this is giving 25 milligram per ml of the sugar solution. This is acting as the stock solution, and from this stock solution prepare for the dilutions as shown in the table. Near about 12 dilutions we have to prepare. 10 dilutions plus 2 unknown dilutions we have to prepare. First we see the first dilution. 0.1 ml of the stock solution, it is diluted to 10 times, and this is giving 0.25 milligram per ml of the first dilution. For the second dilution, 0.2 ml of the stock solution, it is added with the 9.8 ml of the distilled water, giving 0.50 milligram per ml of the dilution. Third, 0.3 ml of the stock solution. To this 9.7 ml distilled water, it is added, and this gives 0.75 milligram per ml of the dilution. Likewise, we have to prepare the 10th dilution as 1.0 ml stock solution added with 9 ml of the distilled water, and this gives the 2.50 milligram per ml of the dilution. Unknown first, it is prepared by adding 0.35 ml of the stock solution with 9.65 ml of the distilled water, giving 0.875 milligram per ml of the dilution. For this unknown second, add 0.75 ml stock solution with 9.25 ml of this distilled water, giving 1.875 milligram per ml of the dilution. Procedure: 1 ml of the sugar solution, it is added with 1 ml of this reagent in a screw capped test tube. The blanket is also prepared by adding 1 ml of the distilled water instead of this sugar solution with 1 ml of the reagent. Heat the mixtures in boiling water bath for 5 minutes and then cool under running tap water. After cooling, add 10 ml of the distilled water to each test tube. Mix the contents on the cyclometer. Obtain for each dilution the optical density at 540 nanometer using blank as a reference. Plot a graph with optical density at 540 nanometer on y axis with the concentration of the sugar on x axis. From the graph, find the unknown concentration of the sugar. This is the result. As the concentration of sugar increases, there is increase in the intensity of the color. Conclusion: the graph is valid and standard if these graphical and theoretical values correlate with each other. This graph is used to calculate the sugar concentration of the unknown samples. Thank you for your listening.